Okay, this is the video lesson for geometry, section 2.5, reasoning in algebra and geometry. So the learning target here is to connect reasoning and algebra and geometry. And this is our first kind of introduction to proofs, which we do a little bit in geometry. And the first things that we learn for proofs is basically if you're, as you're solving problems, right, everything you do in a proof, you have to explain why you did it or prove that that's why you can do it. And so what you need are properties. And so the easiest ones to start with are called the properties of equality. And this is from algebra, right? So the addition property of equality is if you have A equals B and you add the same thing to both sides, right? Both sides are still equal. It's still true. So if you're adding something to both sides, it's addition property. Subtracting something from both sides, subtraction. Multiplying, division, multiplication, division. So these ones are pretty straightforward. These three are new. This one's actually so simple. It's kind of hard because it doesn't even seem like it needs a property, but A equals A. That's a reflexive property. And then symmetric property is similar, but if A equals B, then B equals A. Basically, kind of like you're just switching the sides, right? I'm trying to think of symmetric, right? So if A is on this side and B's on this side, it doesn't matter if you switch the order. Reflexive property is more like a mirror, right? A is A, same thing. Like if you're looking in a mirror, you are you, right? Transitive property involves three different things with a link. So if A equals B and B equals C, B links them, and that means A equals C. It's kind of like the law of syllogism we just did, right? When there's a link, then you can get rid of the link and just go with the first and the last. And then substitution property, which is similar to transitive properties, and sometimes they can be used interchangeably. But if A equals B, then you can replace A with a B in any expression. Okay, so let's see them in action. I think there's one more here, actually, the distributive property. So we've learned this one already. You know the distributive property. If you're doing that, you just say that's the distributive property. Okay, so as you're doing proofs, you can justify steps, as I was telling you. As every step you take, you need to justify it. Right, and we're going to start with solving equations. So you can use properties to justify steps. You can also use theorems, which we'll learn as we go. We'll learn some new theorems. Postulates, which are just sort of like theorems, but a little bit different. And you don't necessarily need to know the difference between that now. And then definitions can also be a way to justify. Okay, so let's see how this works. So say we're solving this problem here. But the only difference is we're adding justify each step. So it says, what's the value of x? Well, we can see from this picture that this is a linear pair, which means these two have to add up to 180. We can say that x plus 2x plus 30, well, actually, let's do, equals 180. This is definition, so we're going to use a definition of linear pair. We might, and some proofs might even have like you write, okay, it's a linear pair, given. Linear pairs are supplementary, definition of linear pair. And then we could write this equation and say definition of supplementary, but we're just going to go simplify this since this is our first stab at these kind of proofs or where we're justifying each step. So we know because of definition of linear pair that this plus this equals 180. So then let's just solve this equation. So remember, if we have to simplify this side. So these two combine and this becomes 3x plus 30. And that equals 180. And we can do that. We can justify this either by saying, you can write simplify, or I would just like to say combine like terms. And then our next step for this would be to subtract 30 from both sides. And then we would write, this is 3x equals 150. And so in these proofs, you actually don't write the step, and you'll see this in the homework too. You don't write this step. You just get to the next spot, right? So this is the first step. This is the second step here. And how did we get here? Well, we subtracted 30 from both sides. So that's the subtraction property of equality. Okay, so when you see these proofs on the homework, you'll see, right, you won't see the minus 30. You'll just see, oh, they subtracted 30 from both sides. So this is the subtraction property. So you don't show that when we're doing this. Okay, and then the next step, we're going to divide both sides by 30. I'm sorry, not 30. We're going to divide both sides by 3, and we end up with x equals 50. So that would be our next step, and that would be the division property of equality. Okay, and that's it. The value of x is 50. And so we've justified each step that we did, definition of linear pair. We combined like terms. We used the subtraction property of equality. Then we used the division property of equality, and we were able to solve x. Okay, so try this next one on your own. And you're given that this bisects. Okay, so they're saying, okay, this bisects. Actually, let me start this off for you. Actually, let me just do this for you. I'm not going to have you try this one on your own. Maybe I'll actually write this in, and then you can fill some in. Okay, so when we do these proofs, we like to do, and I'm just going to start here with statement, and then reason. That's what we do. Wow, it's been a while. Okay, so the first thing you're going to write under your statements is what is given. So we're given that ray AB bisects angle RAN. And the reason that we know that that's true is because it was given. So you're going to write given. Okay, and so the second statement, okay, because we know this bisects, we know that these two angles are congruent. So angle RAB is congruent to angle BAN. We know that because we know they bisect, and that is the definition of bisect. This is probably not what they were going for. I'm showing you the proof. You'll see on the homework that I'll show you what you really need to do, but just don't worry about getting all of this right at once. So the next thing we know is that x equals, and this is where I think they expected you to start, not x equals, sorry, x plus 2x minus 75 equal, oh no, that's not true. What do we know about if they're congruent and the two angles are equal? It was right the first time. X equals 2x minus 75. Okay, and that we know that basically, actually we can say that this is definition of bisect. Let's cancel this. Don't worry about that right now. So we're not going to get that technical. Okay, so this is really where they wanted you to start. But this is just good practice for starting with a proof. Okay, so if we're going to solve this for this value of x, we're going to start here. We know that this is true because we know that the definition of bisecting is. So they have to equal each other. And then we want to subtract 2x from both sides, and we get negative x equals negative 75. So see, I didn't show that we were subtracting 2x. You can, that's fine, especially at the beginning. But we just know that we subtracted 2x from both sides, so this is the subtraction property of equality. And then we need to divide both sides by negative 1 to get x equals 75. And that is the division property of equality. You could have also multiplied by negative 1, so it could also have been multiplication property of equality, but x equals 75, and this is how we justified it. We know they're equal to each other because of we know what bisect, the definition of bisect is. We know if we by the subtraction property of equality that negative x equals negative 75, and we know by the either division or multiplication property of equality that x equals 75. All right. So here are some more properties. Those are just all properties of equality. These are properties of congruence. And I think that's why these three were also highlighted at the beginning of the lesson, because those were specifically properties of equality. This is the same exact idea, but using congruent symbol instead of equal sign. So a segment AB is congruent to AB, or angle A is congruent to angle A. That's still the reflexive property. It's just a reflexive property of congruence. Symmetric, again, if you just switch the sides, but with a congruent symbol instead of equals, it's symmetric property of congruence. And then transitive property, same thing with congruent symbol, right? If A is congruent to B and B is congruent to C, right? The B's link and A is congruent to C. That's the transitive property of congruence. Okay, so let's see how that's going to work. Problem 2 is a little easier than problem 1, I think, because you're just going to name the property that the step shows. So, and then you just need to keep track of if it's equality or congruence. A little hint here: if there's an equal sign, it's equality. If there's a congruent sign, it's congruence. Equal sign, equality. It's an easy way to figure out if it's of equality or of congruence. So this first one here, A, you can see to get from this step to this step, what did we do? Well, we subtracted 9 from both sides, right? So this is the subtraction property of equality because it's an equal sign. And I'll write it out just on pause so you don't have to watch me write all those words. The second one here is of congruence, right? And you can see this is the first step. We know these two things. And we know, right, the W links, and then O is congruent to L. So this is going to be the transitive property of congruence. And I'll write with better handwriting so you can actually read it. There you go. And then the second one, this is going to be of equality because it's an equal sign. And there's only two things. They just switched plots. And that's going to be the symmetric property of congruence. Okay. And just a side note, if you want to abbreviate this as property of congruence, you can do the congruence symbol, right? Property of congruence, or property of equality, or property of equals sign. I'm okay with abbreviations. I don't even like writing them all out, but you do need to write, like on a test, if you just write symmetric property and you don't write congruence or equality, then I don't know if you know it's congruence or equality. So, you'll get a little piece taken off of your score. So make sure you do write whether it's this way or something. Don't just write symmetric property. Okay, try these three on your own. Press pause and then check back for the solution. Okay, so this first one you can see is just two things. They switched order. So that's a symmetric property, and this is a congruent symbol, so it's symmetric property of congruence. Here, this is an equal sign. So you would think it's of equality, but then you notice that's just distributive property. So it's actually just distributive property is just distributive property. It's not of equality or of congruence. I think it's technically of equality, but you can't have one of congruence. But so it's just distributive property. And then F, in order to get X alone, you multiply by 4 on both sides. So then that's the multiplication property of equality since it's an equal sign. Okay, and then after all of that, we get to the definition of a proof. So proof is a convincing argument that uses deductive reasoning. And the way, and I kind of already showed you how to do this. I got ahead of myself here. This is the book teaches proofs a couple of different ways, a paragraph proof, kind of like a mapping proof, but I like to just do it one way, and it's the 2-column proof. I think it's the most logical way. It's the way that once you get higher math that they really do it. It's the easiest way to kind of organize it. I don't like showing too many different ways, and it kind of gets confusing. So a 2-column proof is where you write the statements. And the first statement here is usually the given statement, so that always makes it easy. The last statement is always what you want to prove. So if I'm giving you a start of a proof, you already have your first line and your last statement. And then each statement from here to here follows logically from here to here, and then you give your reason for every move until you have proven what you're trying to prove. Okay, it's very exciting, proofs. All right, problem 3, write your own 2-column proof. Although you're not going to write it your own, I'm going to write it for you. But you're going to watch and you're going to follow along. So we're writing a 2-column proof. So we're going to start with statement, just like I was doing in problem 1. But I think I got ahead of myself there. And reason. Okay. And then we're going to start with the first thing, and that's going to be our given. Let's write our given. So we know that measure of angle 1 equals measure of angle 3, and we know that because it is given. Okay, and we know that this is going to be our last statement, but we don't know how many that's going to be, so I'm going to wait to write that. Okay, and you can see in the picture we've already written that these two are congruent. And what are we trying to prove? We're trying to prove that AEC is congruent to DEB, so these two are congruent. And so that you can see that we're going to be using this 2. So we can say that the measure of angle, we can actually add the measure of angle 2 to both sides. So we have an equal, so the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 3 plus the measure of angle 2, right? And we know that because we just added the same thing to both sides. So this is the addition property of equality. Okay, and then we can see here that measure of angle 1 plus measure of angle 2, or angle 1, sorry, angle 1 plus angle 2 equals the measure, or sorry, measure of angle 1 plus measure of angle 2 equals the measure of angle AEC, right? And that is, and actually we can also say the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. And we know that because of the angle addition postulate that we learned in a previous chapter. Right? Because if you have two adjacent angles and you add them together, they equal the big one. Okay, and then since this equals this and this equals this, we can just substitute those in. So the measure of angle AEC equals the measure of angle DEB, and we know that because of substitution. And that is what we're trying to prove. So as soon as that's our last move, we're done. That's our proof. Okay, and it doesn't have to be done perfectly like this. There's a couple of different ways that you could have done it. There's a lot more steps we could have added, but this was probably the simplest way to do it. Your book probably did it a little different, and maybe theirs makes more sense. So make sure you look at that too to see if it makes it clearer for you. And these just take practice. So this is your first stab at it. So don't worry if you're not getting it right away. You'll get the hang of it. Okay, so there's one for you to try on your own. So it's actually pretty similar to the one that we just did, but it's a segment instead of angles. So press pause and try your best at this one. Just make your 2-column proof and then check back for the solution. Okay, so here's the 2-column proof. Pretty technical and stuff we haven't gone over, so just feel good if you even thought it through correctly. So the best thing is really to do is just kind of look and see, all right, if AB is congruent to CD, and I've added the marks here, the marks were not given on the picture, prove that AC here equals BD there. Well, that makes sense because BC equals itself. I guess I could have thrown in a reflexive property, but I didn't think we really needed it because, so what we did here was we started with a congruent statement. But in order to, and I wanted to add this BC to both sides, but you can't add something to a congruent statement. So I turned it into an equal statement by just saying, right, if AB is congruent to CD, then AB is, the length of AB, which is just written AB without the line on the front, is equal to CD. So that's the definition of congruent. So these two measures equal each other. Then I can add on the measure of BC to both sides. And when I add both things to both sides with an equal sign, right, then it's the addition property of equality. Then I can add when there's an equal sign. And then I can state that AB, this side, right, is equal to AC. And these two together are equal to BD. That's because of the segment addition postulate from an earlier section. And then once I have that, this I can substitute in for that. This I can substitute for that and write that AC is equal to BD, which is substitution, which is, we're basically done. But remember, we're trying to prove that AC is congruent to BD. All we have done is that AC is equal to BD. So then we rewrite it as a congruent statement. And because AC is equal to BD, then we know that the two are congruent because of the definition of congruence. So that's technically how you do that one. And then, yeah, so try this on your own. There's a lot of proofs here, and a lot of them are just written out and you just have to write the reason. And a lot of it is just this addition stuff. So this is just your introduction to proofs. It gets easier, I promise, and it gets more fun and you learn more theorems and more properties to use. And yeah, so enjoy.